All right, guys, here we go with our next example. We're working on example 4 in the notes. We're looking at write 1 over 5 plus root 3 in simplest form. Okay, so if we look at this and we take 5 plus the root of 3, let's take a look at our denominator. Okay, 5 plus the root 3. Now, remember when I was talking about how you cannot have a root in the denominator. You cannot have that root down there. So this root 3, we've got to somehow get rid of it. Okay, but we can't just take the entire denominator and multiply by root 3, because when we multiply it to both pieces, that root 3 would still be here with the 5. Okay, so what we actually have to do is we have to multiply the entire denominator by the conjugate. Okay, that's the only way we're going to get those root 3's to go away. Okay, and then remember, whatever you do to the denominator, you have to do to the numerator. Okay, so if we take this and let's say we go through and we, multiply everything together, when we do that, so if we take 5 plus root 3 and then 5 minus root 3, okay, and you guys know my slight obsession for the box method. 5 times 5 gives me 25. We've got 5 root 3 here, and then we've got negative 5 root 3. Okay, so sweet, that's awesome for us because those roots will end up going away, right? That's always our goal, is to get those roots to go away when we multiply by the conjugate. Okay, well then if we take the square root of 3 times the negative square root of 3, that's just going to turn out to be negative 3, okay? Or if you look at it this way, if you multiply whatever's underneath, it's the square root of 9. If you take the square root of 9, that turns out to be negative 3. Okay, so in our denominator, we have 25 minus 3. In our numerator, if we take this 1, and we distribute it through to both pieces, doesn't change anything about our numerator. We just have 5 minus the square root of 3 in our numerator. Okay, then we have to go through, we have to simplify that denominator because we know how to take 25 minus 3. So we have 5 minus the root of 3 over 22. And there's our final answer. Okay, so make sure we understand the conjugate. We're just multiplying by the opposite. Okay, let's take a look at the next example, example 5. Okay, and there's actually 3 mini examples here. Okay, again, we're going through and we're simplifying each expression. Now, one of the main things I want you guys to go through and look at and observe, especially if we take a look at letter A, we have the 4th root of 10 and the 4th root of 10. Okay, that's awesome for us, right? If we think about it, if we try and take the 4th root of 10, that's not going to give us a nice number. Remember, that's kind of one of our common themes today. We're looking for nice numbers. If we can't take the 4th root of 10, we just leave it alone. But what's the imaginary, not imaginary, shouldn't use imaginary. What's that invisible number that's out front of this 4th root 10? Well, it's 1. Okay, so really what you're looking at doing is you're looking at combining these numbers out front. Okay, as long as the roots that are behind it, as long as the roots that are behind those numbers are the exact same, so you've got 4th root 10, 4th root 10, then you can combine. So 1 and 7, that'll give you 8. Okay, 4th root of 10, 4th root of 10. I don't know why I'm attempting to write 8 here. Will give you the 4th root of 10. Okay, so your ending answer will be 8 4th roots of 10. Okay, now taking a look at letter B. Okay, kind of the same concept, really. If you think about it, and if you look at it, look at what we have here. We have 8 to the 1/5 and 8 to the 1/5. Okay, again, if we were to change that 8 to the 1/5 into our radical form, it'd be the 5th root of 8. Now, is the 5th root of 8 going to turn out to be a nice number? No, it's not. Okay, so let's just keep it as 8 to the 1/5. Let's take a look and deal with these numbers out front. Okay, we've got 2 8 to the 1/5 plus 10 8 to the 1/5. Again, just combine these. Combine your like terms. Okay, we end up just with 12 times 8 to the 1/5. Now, again, a lot of you are going to want to try and multiply that 12 and 8 together. You can't. You cannot multiply those together. You have to keep them separate because 8 to the 1/5 is not a nice number. Keep them separate. This is as simple as it can go. Okay, now if we take a look at letter C, okay, you've got the 3rd root of 54 minus the 3rd root of 2. Okay, we kind of want to start thinking again, what are our perfect thirds? Because right now we can't combine these. Letter C is not anything like the first two. The first two had the exact same root, had the exact same 8 to the 1/5, 8 to the 1/5. This does not have any common terms right now that we can combine. The only thing that's in common is that there's the 3rd root there. Okay, and just because it's the 3rd root doesn't mean that we can subtract them. Okay, what we have to start searching for is, I somehow want to get the 3rd root of 54. I want to change that so that I've got a 3rd root of 2 in there somehow. Okay, so let's go through, let's start thinking again, what are some of our perfect cube numbers? 2 to the 3rd, that's 8. 3 to the 3rd, 27. 4 to the 3rd, which hopefully, like I said, we're kind of starting to memorize a few of these, which would be awesome. 4 to the 3rd gets us 64. Okay, now, is there any way that I could break 54 up so that I come up with a 2? So if I take the 3rd root of 54 and I break it down, okay, could I take 2 times some number and come up with 54? Yes, I can. That lucky number 27 is in there. Okay, so I can go through and I can simplify. I can simplify this 3rd root of 27 into 3 times the 3rd root of 2. Okay, so if I change this, now I can deal with this a little bit more. 3 times the 3rd root of 2 minus 1 of those 3rd root of 2's. Excuse me. So if I take 3 3rd root of 2 minus 1 3rd root of 2, I'm going to come out with 2 of those 3rd roots of 2. Okay, so there is our 5th example. Now I've got an entire another slide full of problems that are similar to this. What I want you guys to do is I want you to go through and pause and see if you can work through some of these. Okay, I'm going to go through, I'm going to pause the video, and I'm going to go through, write all of the solutions out, and then test yourself. See what you can do. See if you can remember all of the examples that we've gone through and done so far. See if you can apply those properties that we've talked about. Okay, so take a second, pause the video, go through these examples if you want to, and just test yourself. Try and do whatever you can. All right, guys. So hopefully you went through and you worked out a couple of the problems. Here is all of my work. I showed absolutely everything that I possibly could. Okay, so We've got 5 through 8 up on the top, 5, 6, 7, and 8. Scroll down a little bit so you can look at 9, 10, 11, and 12. Okay, there's those 4 answers. If you have any questions on them, please, please, please make sure you stop in tomorrow morning or tomorrow after school. I know it's Friday, but even sometime next week, if you're going through these and you're not totally sure, you're struggling with some of them, please, please, please make sure you come in and ask me any questions at absolutely any time. All right, we're going to go through and we're going to look at examples 6, 7, and 8 in the next video. We'll see you in a couple minutes.